Welcome to Full Throttle RC, presented by Warehouse Hobbies. I'm your host, Tony Castronovo. In today's episode, we're going to talk about fine-tuning and adjusting your boat, whether it be for competition or sport performance. We're going to show you how to adjust hardware, how it works, and show you the proper way to get the most out of your model. So we'll see you soon. Come on back. Stay tuned. This is the new long-awaited Silex race boat that we've been producing since the beginning of last summer. And we just got it ready and in production a couple weeks ago, and it's doing quite well. The boat's winning competitions, or it in the last couple races that before the season got a little bit too cold up north, we did really well, and a couple of our factory drivers actually took home the gold. So we're quite proud of this model. And Chris, get some pictures of here so you guys can see what it looks like. It's 47 inches in length. It has a beam of a wetted surface of 13 inches. It comes the way you see it. It's a race prep boat. It features our M6 engine, powered by Zenoa, modified by us, of course. Dry-tuned exhaust system. Has an integral radio box. This is really unique. We designed this radio box and platform as a one-piece unit, and it sits down inside the boat, and it attaches with 6 screws around the perimeter. And to remove the radio box, you can do it in its entirety by removing the 6 screws and lifting the entire tray out. The whole plate radio box all comes out. It can be taken out in under 5 minutes and then replaced. The beauty of this is the wind coming over this boat doesn't get spoiled into the hull. It actually deflects, sort of like a cover on the rear of a pickup truck. So that was the whole purpose for this design right here. The freeboard on the boat, the width, the height, is less than 1.5 inches at its widest point. And it makes it beautiful for cutting through the wind without any type of high size for the wind to disturb. Also, the edging of the boat is a sharp, true edge that does not have a shoebox like our conventional boats or conventional full-size boats. It is completely sharp, so there's no place for the wind to grab underneath it. We're very proud of this model, and I'll tell you what, the results are unbelievable. This thing comes out of the box between 60 and 62 miles an hour, and those are race competitive speeds. So if you guys can drive, you could take a Silex and be very competitive with it. This is a beautiful thing. The finished weight, guys, I know you're not, most guys that know enforcer boats, we build our boats a little bit on the heavy side. Most of our hulls are in the 7 to 8 pound, 9 pound range, depending on the size of the boat. The Silex is built by weight, not volume. So all the materials are weighed prior to building each hull. Every hull comes out consistent between 5 pounds and 5.2 pounds with the finished weight of the boat at 13.5 pounds, ready to go, including radio system. Take a good look at it, Chris, so the public can see it. We also are offering this boat completely assembled in what we call the Silex Pro version, like you see it here, with anodized hardware, anodized engine, with the radio system. This boat can be bought for under $1,500. Less radio, it can be bought assembled at $1,375. And we are taking orders and in process of producing right now. Okay, let's get started. First, let me talk about some of the hardware that you'll find on this boat. And we'll start with the Silex race boat since it's here on the desk. And then we'll progress into, maybe we'll do a Super G, something a little bit on the easier end. But let's talk about the hardware that you'll find on a race boat typically. Okay, starting with the drive system. This is called our RD1 drive. It's very similar to the SPD3, just a smaller version. It extends from the back of the boat about 5 inches from the leading edge of the prop. This puts the prop in cleaner water conditions, and the water breaking off the transom isn't disturbed, causing any cavitation in the propeller. So it's bringing the prop back. Also, it has a planing surface, just like the SPD3, so it can literally stabilize the boat on the bottom pad of the drive itself. We feature an offset rudder, which you'll also see very common on race boats. In this case, offset to the right. We run a typical, I believe we run a 2-inch offset on this boat, and that allows the boat to make fast right-hand turns. Now, yes, you lose a little bit of left-hand turning capability when you offset the rudder. However, in racing competition, you're running right-hand rotation. So we want a snappier and more predictable right-hand turn. Okay, then we have our trim tabs. A little bit different than what you're normally seeing on the large enforcer boats. These are competition trim tabs where they're only about 1.5 inches off the back of the transom, about 1.25 inches wide. And notice there's 2 on each side, and they're spaced out. And the reason they are is so you could fine-tune this boat. Each trim tab is machined and has a fine-tuning 632 screw here, which you either loosen or tighten to change the attitude of the trim tab. And we'll get to how trim tabs work a little bit later. Next, we have the turn fins. And you'll notice a large one on the right side of the boat and a smaller one on the left. And the turn fins basically do what they say. They create a faster, more predictable turning on the boat. And I'll get into that in a couple seconds too, more into detail on that. But basically, there's your rudder package, and the hardware package you'll find on a race boat typically is this situation right here. Okay, let's talk about the drive system first. And I have an RD1 body here and also an SPD3. Now, when I first designed this particular product back in the late 80s, you'll find this may be possibly amusing, and is it was round. It didn't look like this block that it does today. We originally started out with this device round. And actually, I had someone in the hobby industry at the time that was making model boats, had a little machine shop, and he was building the first SPDs for us. Those are called the original SPD, which stands for surface planing drive. And what we found with a round drive was that it created problems at top end. Now remember, I'm going to back up. I'm going to back up before we were running 40 miles an hour. When we were in the 30s back then, you'll notice I always reference back to the olden days. It's a good basis. When we were in the 30s back then, we didn't find any of these problems that we started experiencing when we started hitting the 40 mile an hour and plus mark. Whereas we started running out of hull at speed, and that would literally make the boat what we do chine walk. And chine walking takes place when you run out of boat. And when you run out of boat and you have nothing to balance on, very little to balance on, the torque of the engine is going to cause the boat to do this. And that's what you guys might be experiencing in some of your boats. You get at the top end and the boat's just very unpredictable and out of control. That's called chine walking. So, I don't know if we ever touched on this in any of the shows. That's when I looked into out drives, and for instance, the real boat company, Arneson, was making a long drive, 6-7 feet off the back of the boat. And I went over to his factory and I asked all kinds of questions. And they told me that's what they did. They wanted the prop in cleaner water, and they wanted to gain control of the boat. They actually wanted to take the prop further off the transom to add, he used to tell me to add to the length of the boat without adding to the friction surface. And that was pretty intelligent. So I went back and made the first SPD, and again I made it round because the real one in real life was round. But then we started to go faster. We experienced the boats chine walking still. We'd get quicker in the boat, and it would actually start to ride on the plane. We could watch the boat go by and ride on the round surface, and you'd see the boat teetering and out of control. So I went back to the shop one day and I had this idea. What if, obviously it's much harder to make a flat surface, teeter back and forth. So I sat down and I worked with a couple different surfaces. And if you look at the SPD3 here, I worked with a flat surface, and initially I started out with a 1/2 inch, and the boat ran fantastic. I got rid of the chine walking. That almost went away, but then I couldn't turn the boat. It was really difficult to turn it. So we started working with different surfaces and different degrees and angles, and it was pretty simple. We established a 65-degree angle on each side with a 1/4 inch ride surface, and the theory being that we can actually start planing the boat on this surface here, and then when turning the V and rotating it, the angle made it easy for the boat to roll. And by making it easy for the boat to roll, we can make it easy for the boat to turn. And the same theory applied with the RD1. When I did this particular drive that you see on the side lights, we ran the same 1/4 inch and the same 65-degree angles on each side. And that's how we achieved an after-planing surface on the drive. And hence, the SPD came to be, and into the 3rd generation now, and very successful with this drive. Okay, since we started with the drive, let's start with the drive on adjustments. That's the first thing I like to adjust when I'm running a model boat. Because you have 2 typical things that will make the bow attitude change, go up and down. And that's going to be the drive system and obviously the trim plates. Okay? Rudder has a little bit to do with that too. We'll talk about that later. Okay? Basically, start your boat parallel. Start your rudder parallel to the transom. Okay? The leading edge at the top of the rudder to the bottom is basically parallel with this transom. Okay? The drive, I like to start that parallel, and here's how you do this. You take a good straight edge, you put it under the boat against the bottom of the keel, okay? And I've left this loose so you can see how it adjusts, how the RD1 adjusts typically up and down with this small adjustment screw here. Then you can lock it down. But I'm going to pull it down until I get from the front of the drive to the back of the drive, right part of the drive dog, is about the same level, and that's parallel. So at this point, we'd lock this drive down and start it. Now, the same thing goes with the trim tabs. The first time you go out with your boat, set everything neutral. You've got to see how the boat handles first before you can start making adjustments. So you take your straight edge and put it under each trim tab, and basically what we would do is we would dial each trim tab up until it's level, it's even at the front of the tab to the back of the tab, the same amount of gap. Okay? Also, you'll notice, this is important, the trim tabs on our models, and generally most models out there, are not flush to the bottom of the boat. That's the last thing we want to do. By putting the trim tab flush to the bottom of the boat, we're now adding that wetted surface. We're adding an extra 1.5 inches of friction to this boat. So we bring our trim tabs up. In this case, on a race boat, we go a 1/16 of an inch up from the bottom. On a sport boat, sport performance boat, will be about an 1/8 inch up. And this allows just to tip the back section of the tab right here to do the work. So they're basically not dragging an entire trim plate in the water when you're running. So go through all your trim tabs and set everything neutral. So they're really basically not doing anything. Okay? And that's how we're going to get started. Okay, let's talk a little bit about the turn fins before we go into anything else. The turn fins, like I said, the large one on the right and the small one on the left, is to aid in the boat's turning and get it a little bit more stable in the turns. And why this works is simple, okay? The rudder on your boat obviously controls the direction of the boat, okay? This way, the water is going to be deflected and push the boat to the right. This way, the water is going to deflect and push the boat to the left. But what makes the rudder really work is opposition. Something has to oppose the rudder. Something on the bottom of the boat has to oppose the rudder. If you had a flat bottom and a rudder hanging back there and you went to turn, the rudder would act more like a brake rather than a turning device. Eventually the boat would turn, but it would take a great distance to do so. So in a deep V or a V bottom or a mono where you have a keel on the bottom of the boat and it's basically a V, the keel is your heavy opposition to the rudder. So your boat will be running down the straightaway, full speed. You maybe pull back a little bit on the throttle, a hair, and it settles, and the more of the boat starts running in the water. Now the keel becomes a pretty long rudder in essence. And when you turn the main rudder, you have a lot of opposition against this, so instantly the boat wants to turn. And a V will roll over. If you're making a right turn, it'll roll to the right and turn. Now, why we do this on race boats, and especially surface drive, is what prompted turn fins back in when I started messing with this in the late 70s and early 80s with surface drive. And the reason being is because the prop is basically running on the surface of the water. And if you put a straight edge on the bottom of this boat and look where the ruler was, take a good look at this. Chris, if you can zoom in here. If you are planing on the bottom of this boat right now, your hub is basically planing on the water. So, in essence, every time this prop goes around, let me scooch the ruler up, every time this prop goes around, there's only one ear in the water. That's how surface drive works at any given time. Okay, what happens with this is, it's the great thing. We know we can go with larger props. Larger props mean more blade area in the water, and the faster we go. We can unload an engine because we can only have one prop in the water at a time. So we can get a boat to go faster. But where the drawback comes with surface drive is, with all that mass on the back of the boat, when the boat rotates, rolls forward, starts to make a turn, we have a weight transfer situation where the weight transfers towards the front. Just like a car diving into a turn. And obviously it's getting lighter in the back. Well, let's think about what happens. This boat tends to want to lift in the back going around a turn. The prop is on top of the water, and there's a lot of force against this prop. This prop can make a lot of power. And it tries to walk itself around. Literally will try to walk on the water. And that's why if you guys experience going faster in a turn and you nail it into a turn and the boat wants to do 360s, you've transferred the weight quickly. The back end got light. The center of gravity went way too far forward and the prop helped it just run right around. So by putting turn fins on the back of these boats right here, not only are we relying on the keel, but think about what happens. We're closer. We're putting the opposition to the rudder closer. So the rudder is going to react much quicker. So when we go into a turn, the turn fin in opposition to the rudder is going to happen quickly, and it's going to cause the boat to quickly turn. And also with the turn fin, it's going to help anchor the boat. It's a resistance. It's going to help keep that boat in a turn and not trying to spin out. And if you look at the way we do this, again, back many years ago, we basically would run the turn fins straight up and down. Okay? So they were in the water at all times. Well, the problem with that is when you're going through the straightaways, you're also dragging them. There's guys that still do this today. So you have unwanted resistance in the water. So what we're doing today is we basically set the boat up where we'll turn the boat, we'll lean it down maybe on a flat surface like this, so when the boat is flat on its turning pad, the turn fin becomes 90 degrees to the water. So when the boat is in a straight position like you see it now, they're technically out of the water. As the boat planes and goes at full speed, the boat's planing somewhere in this area right here, your turn fins are not giving you added resistance. That's how that works. Okay, let's get back to adjustments. Okay, our boat's ready to go. We've checked everything out. We're going to run it for the first time. We have no way, we don't know what we're doing adjustment-wise, but we have everything neutral, and that's a perfect place to be. You want to put your boat in the water now, get familiar with how it reacts, break the engine in, take your time, go through a tank of gas, break the engine in, and then you can start experimenting with how the boat reacts to different adjustments. And remember, water conditions are the main player in this. Okay, if you're out there in a situation where the water's dead calm and you have no ripple on the water, you have no real effect to create any additional lift. So you're relying on the design of the hull, the hydrodynamics of the hull, and the engine power and the right combination of the prop to do the work for you. And in that case, by having everything neutral, like the trim tabs, not doing anything, you're going to free the boat up, and it's going to run pretty well. You might find that it runs a little wet. You might have just a little bit too much nose in the water, and obviously the more nose you can get out of the water, the faster you go. However, the less stable you become. So this is a balancing act you have to figure out. So let's say that the water is calm, and you come back in and you want to make a change. Well, there's really only a couple of changes you can make at this point. Okay, providing the boat is designed right and the center of gravity is designed right, and you have all the power you need. You can raise the drive a little bit, and you could pull the rudder back a little bit. Okay? A lot of guys don't know this about the rudder, but the downfall to pulling the rudder back is you lose a little bit of your control too. On a dual rudder boat, which we can get into later, or I'll just touch it real quick. On a dual rudder boat, you have a little bit more leadway because you have two rudders in the water. You have more surface area. But on a race boat where you have a small rudder to begin with, and these rudders are anywhere from 1 inch down to 3/4, you can't exaggerate that, or it will affect the way you turn. But if you took this rudder and you brought it back slightly, okay, maybe 1/4 inch, 1/2 inch, and you pulled that rudder back, that'll help induce bow lift. Okay. Also, bringing the strut angle up, and I'll explain how that works. Put your straight edge back on the bottom of the boat like this, and basically bring your strut up a couple degrees. Now, don't go nuts with this. Okay. First off, it puts unnecessary bind on the cable, plus it becomes inefficient really quickly. It only takes a couple degrees of positive up or positive down to make a difference. Now, with the angle up, okay, you can pretty much see how this works. I'm going to exaggerate and leave it up high right now. The prop is going to bite and force its way downward, and as it does that, it's going to force the bow up. Okay? Now, let's talk about efficiency. A lot of guys love it. They call me and say, my God, I got a 20-foot rooster tail and it's 10 feet high. Well, let me tell you something. That's not efficient. It looks cool, but it's not efficient. Efficient is when the rooster tail is low meaning in a model boat a couple feet, maybe 3 feet, and long, 15, 20 feet long. If the rooster tail is coming out of the back of the boat straight up in the air like this, 6, 8 feet high, you're not running efficient. You have the wrong angle of attack on the prop. You're way too high, and that is losing speed. Like I said, guys, it looks cool, but you're not going anywhere. So you want to try to find the best combination between adjustment of the angle of the prop and the rooster tail is the easiest way to find that. Look for a low, long rooster tail, nice and clean, and that's how you do it. Okay, let's say the conditions are really rough, and this boat handles really good in 2 or 3 inch chop, but let's say it's worse than that, 3, 4 inch chop. That's tough for everybody, okay? In that case, what you want to do is, first thing you want to do is we want to start from the neutral position and start working with our trim tabs. That's number one. We want to lower them a little bit. Use your straight edge. Now this is where you need a pad and paper, and you have to basically write down, okay, these are the conditions of the water. I'm out at the lake today. The water chop is about 2 inches. Okay? Really 2 inches, guys. Really like 2 inches. 2 inches to a model boat is pretty big. That's about 10 times. That's about 20 inches in real life. Okay? So, and 2 inches is 2, 3 inch chop's pretty rough. You start lowering the trim tabs a little bit, all four of them, okay? Keep your drive neutral, set in the middle, and try running the boat. And try to get as much speed and maintain control as you can, all right? You might have to come back and adjust them a little bit more, get the bow down a little bit more, okay? And again, we want to run the trim tab. The last thing you want to do is adjust that drive. If you have to push that drive down, I mean, in some cases you might get to a race or go out and play one day and the water's just so damn rough, 6, 8 inch chop, you've got no choice. And at that point you can't utilize the speed of the boat. You're going to have to run the drive down negative, and by negative meaning downwards, like so. And you can see how this can happen, the action. The water will come off the bottom of the boat, hit the drive lifts, tries to get to the surface, and pushes the bow down. Okay, in the case where it's just too rough, you have to live with it. But what you don't want to do in a situation where you have good water, decent water, a little bit choppy, you don't want to drive too much of the boat in the water. Remember what I told you about bow steering? If you get too much of that boat in the water, in other words, you're too far forward of the center of gravity of the boat, you have all this massive keel in the water. Now the rudder's reaction is very sensitive. All you do is twitch on that rudder and that boat wants to dart. Okay, and that's called bow steering. So again, it's best to do this and document everything with a pad and paper. Make one change at a time. If I don't say that a million times, don't go out there and say, oh, I'm going to crank both of these here, this here, move this here. You'll have no idea what you did right or wrong. One change at a time. And when you're learning, especially racing, when you're learning how to race, there's a couple factors. You've got to learn how to drive. Just because you have a 62-mile-an-hour boat, you can end up being a terror out there with the guys, okay? You've got to learn setup and driving skill. So you basically want to spend quite a few days and weekends at the pond by yourself or off course, learning everything there is to learn about your adjustments and how they affect your boat. Document everything. Document the date, the weather, what you did, if you made a change, down to a spark plug change. All of that is important for you to become a good racer. As far as a sport performance model boater, obviously I want you guys to learn as much as you can. You need to know the fundamentals on how all this stuff works, okay? You can live with a little bit lesser than perfect, whereas in a racing community, that's not the case. The boats today are fantastic, the engine builders are fantastic, and the drivers are unbelievable today. I know we have one. We have a guy that we commissioned that's phenomenal. He's one of the most famous electric drivers in the world. His name's Paul Packmeyer, and he started racing for us on gas, and he's fantastic. So before you can go up against a guy that's a fantastic driver, you really have to understand your equipment, how to use it, and understand the conditions that apply. Okay, before I change the subject, I want to talk about choosing a prop. This is really important. Okay, basically, you buy this boat ready to run or you buy it in pieces from us. We can tell you, and we know what works. Between the guys who've been testing for the last year and ourselves, we know what works. And the same goes for other manufacturers. Very important. You can get yourself an entire arsenal of props that cost a fortune, and to find that some don't work for your application, but your buddy could take it and boy, it screams on his. Okay, very important when choosing a prop. You choose a prop by hull design, the amount of power the engine produces, okay, the design of the hardware. Generally speaking, in a race boat, they basically are anywhere from, these are anywhere from 45 to 50 inches long. Generally, they're running 67 millimeter 3-blade props, 70 millimeter 3-blade props in this case is a 70 millimeter 3-blade, 72 millimeter 2 blades. You get where I'm going with this. Most of those props are relatively smaller. So they stay between the 67 and 72 millimeter range. Some guys are pushed to 75 millimeters if they're making enough power, or they can handle the torque effect caused by the larger props. Most of the guys today are going toward the smaller 3-blade props. Makes a lot of sense. Smaller diameter, extra blade, okay, more pitch. You sacrifice a little bit on takeoff, but on a race boat that really doesn't matter because they have no clutch to throw them in the water anyway. But basically that's the direction that you're going with props. Call the manufacturers, call me, call anybody in this company. Ask them, tell them what you're using. Tell them what you're powering your boat with, and they can recommend where to start. But to go out and just start spending money on props, that can get very costly. So props are very important today. After 25 years of me doing this, it's neat to see all the prop manufacturers now and all the customers. I can't tell you how cool it is to see the customers work those propellers. I used to talk to Tom Persinka, Mr. Octura himself, 25 years ago, and he would say, because I can't understand, everybody spends all this money on their engines. This is back in the nitro days too. Everybody spends all this money on their engines, and they're messing with the boats, but they're missing the point, and it's in the propeller. And they're right, and you can see that today with all these great manufacturers coming on board with all the prop technology is fantastic, and I'm glad to see that. So propellers are important. Talk to these guys. They should give you the information you need. Okay, let's talk about something other than hardware that's very, very important on a racing boat, okay, or a sport performance boat. If you want the ultimate out of your boat and not spend a lot of money, this is the #1 thing that needs to be done. And again, as a manufacturer, we know this, especially on the racing boat, how important this is. But I can tell you this, no boat comes out of a mold perfect. It's not physically possible. If you know the procedure on how you make a model boat or a real boat for that matter, they start out as a plug. A plug, they can be built out of anything basically in real life, or a model, mostly out of wood. Some cases in real life out of foam, or even in models. We still use the conventional method, and we build out of hard woods. We use a CNC machine to rough cut the design, and then we spend several months on literally hand finishing the product. And let me explain what happens in the progressions to get to the point where you can get this particular product. You start with this pattern, and the pattern being the plug, and you make it as smooth as you possibly can, as straight as you possibly can. Because if you understand hydrodynamics, how water works on a flat surface, okay, versus a round surface, is real important. You want the water, you want this product to sit on top of the water. You want the bottom of this boat to stay on top of the water and physically skip over the water. You want a nice clean transition to plane. The more round areas you have, whether it be on the keel or the strakes here, the more round areas, they create more of a suction effect. They don't let that water, they don't let it stay on top of the water and break off clean. They create a suction effect, and that holds the boat down, okay? Another very important thing is called, and I'm sure I went through this in one of the episodes, and I think it was on a gel coat repair, so you might want to go back, I remember doing that last year, and watch that one, because it's very important. I show you how to fix the bottom of a boat, or we call it blueprinting, and that is god-awful important. If you're a racer, and you're good at what you do, and you're a great driver, you've got your engine program dialed in, you need to be really looking at this part of it, and actually this should be like the first thing you do. Okay, we make the plug. After the plug is finished, we have to physically spray that plug with gel coat, tooling gel, which is a higher grade of the product that's on this right now. And then we take that and we block sand that, and hours, making everything sharp and straight. And when that's completely finished, and I'll condense this really quick, we pull a mold off of that. Well, from the time that we lay the first layer of fiberglass, wet fiberglass, over the plug, which has been sprayed with the gel coat, the tooling gel, it gets tight as it starts to dry, and there's ways that you can make this better, but you can't avoid it. And as you put another layer on it, it gets a little tighter, and things change. So when you pull the mold out, now you popped it off of the plug, the mold might have a little bit of imperfection in it. That might have gave a little bit. So it's sort of like recording tape. You remember the days we used to record on tape? You guys, especially musicians out there, will know this, because I fought this all the time. You record on tape to tape to tape. Every time you record it, the worse it got. By the time you got to the 4th or 5th recording, you could hardly understand the song. And we lived that life. Today, you know, with music, forget it. Everything's digital and perfect. But let's look at this like tape, okay? So we take the mold off. Now, let's say that mold is as good as it can be, and then we make a part, okay? Or in some cases, even in our cases, we have to make a master off of that. So now we have the first mold, then we take and make a heavy part in there, same thing backwards, one layer at a time until you get it done, then you pull it off to be a master. Okay, so this particular master will make all the rest of the molds. I've now got, what, 3 generations, or 2 generations off of the original pattern. So I could have lost a little bit more. Okay, so providing you start out perfect in the beginning and you do everything right to get to that master, you're real close. Now you take the master and you make what we call mother or daughter molds off of it, which are the actual production molds. And that master, when it's done, will get put in storage, along with the master mold. The first one gets put in storage just in case anything ever happens and you had to remake them again. But you've now, everything coming out of that set of the daughter molds could be a little bit less perfect. Okay, so now we're 4 generations. Then we make the boat. And that's where it stops. That's the 5th generation. So you can see, if you lose a little bit every progression until you get to the product, by the time you get here, your perfectly flat bottom of a boat is not perfectly flat anymore. It could have a little discrepancies in it. It could be really close. It could be the size of a human hair. I mean, that's what we shoot for, believe it or not. When we do something like this, we shoot for that close tolerances. But in real life, I remember working for a racing boat company once, and I did that on weekends to learn how to do the fiberglass. I think we talked about that. We used to take, these guys made serious offshore race boats, and they would pull a 38-footer, 40-footer out of the mold. The first thing that thing would be done is turned upside down, and a bunch of guys with block sanders, including myself, were massaging. and we were sharpening everything up. And you'd be amazed how many little hook or whoop-dee would be in the boat. And a hook is where you have a negative, where it's a little bit of a negative, and then you can have a positive. And if you have a hook, what happens, they're both bad, but a hook would create, when the water's going across the boat, it creates a suction effect in that area, and it pulls the boat back. So if you have a hook up here in this area that works, you can literally have a boat that you can't get out of the water. It's stuck there. Okay, so that's called blueprinting. Let me touch on it really quick because I don't want to make this episode go too long. I think we talked about this once, and we do that with a good sharp straight edge, and you know you've got a good rule, okay? Start at the keel, and you work your way down, okay? And you look under that ruler, and in this case, even with the Silex, you know, I can see maybe the thickness of a piece of paper in this area right here. You know something? I would probably live with that. A piece of paper, that's nothing, okay? And I get to the keel, looks good. This side's damn near perfect, okay? I can't see any light on this side. But I saw a little area right here. But I would live with that. Now, if I was a racer that did this and I was real serious about my trophies, I would literally take this section right here, and I'll show you where it is, right in this area right here where I see a little bit of a slight indent in, and I would sand this off with some probably 400, 320, 400, wet, take some gel coat, like you were bound to in a car, smear it on there, and then go back and block sand it. And make it perfectly smooth. I don't care what the bottom looks like. It doesn't matter if you got little spots. As long as you use the same material. And in this case, we run in gel coat. So you can run gel coat and you mix it. I think I went through that on a show. You mix the gel coat with a little bit of talcum powder and cabinets. So I think I went through that. So go back and look at that. But that's called blueprinting, and God awful important. Okay? Same with the strakes. They need to be nice and sharp. Everything's sharp. Okay? On our production enforcers, where people buy to just experience fun, we're not as anal about that, okay? First off, the sharper the strakes, the harder it is on the molds. But in the Silex, we know what market we're after on this, and we've got to be up there with the best of them. So we have these strakes pretty much razor sharp, okay? But hey, as good as we are, it does not hurt for you to take a boat, turn it upside down, and say, hey, look, I got a little bit of a imperfect area there, or I got a little bit of a dip, let me fill that in. Or a high spot, you call me, because that shouldn't be, okay? But a hook is a representation of the fact that it's going to happen because the fiberglass itself will relax a little bit, and it amplifies if the molds have these problems. We are so careful about, in the stages of making our tooling, that when we get to the mold, if we have to work a mold slightly to make sure we have a flat bottom. So, if you buy from a manufacturer who started out with a plug that wasn't right, who made his mold that wasn't right, who made his master that wasn't right, and on down the line made the production molds, before you know it, you're going to have all kinds of problems on the bottom of the boat, and that could very well be the reason why everybody's passing you, and you have the same engine, same prop, same design, and they're whipping your butt. So, number one is the bottom of the boat, and that's called blueprinting. So, I wanted to touch a little bit with that. Okay, and I know there's an episode, I look up the gel coat episode, I think in there I go into detail on that. So when you get your race boat, turn it upside down if you got a little bit of time and a little bit of sandpaper and a sanding block, and it is necessary, you might turn your boat upside down home tonight and, oh my God, you know, I didn't know I had that, and that's your problem. You'd be surprised on what that would do to the running surface of a model this small, what that would be like, okay? So it's a good idea to learn how to blueprint your hull and do so if you're racing especially. Chris is telling me we got to quicken this thing up. You know, we were talking about actually lowering taking our segments down to 15 minutes, but I told him I don't think it's possible. I got too much to say, and he's telling me right now that we're running out of time. So let's get to the basic sport boats, and let's go after our largest consumer base. Okay, it's basically the same concept as I showed you on the Silex, a little bit more simpler. Okay, you'll notice we have larger trim tabs on these boats. Okay. Design, again, you know, these boats are designed for rougher water, so we learned years ago to make extended tabs, make them easier to adjust, make them respond quicker. Okay, and this is the XP2 drive, and I'll show you how you adjust this, you guys. Everything's basically the same. You take your straight edge before you go out and run the boat the first time. You know, it's important to put everything neutral. I think when we send them, my guys neutralize them all, so everything's pretty much sent that way. Adjust your tab so it's doing nothing. The gap between the leading edge is the same as the trailing edge. Go to the other side. Same with your strut blade. Come to the bottom of the V of the boat. Chris, can you see this? Let's back this up. Come to the bottom of the V of the boat, okay, and look at your ferrule, the leading edge of your ferrule, to the trailing edge of your strut blade, and get that the same amount of gap. Okay, that's how you set everything up neutral. Same with the rudder. I'm parallel to the transom on the rudder. Now I'm going to go out and run the boat, and I'm going to get the feel of it. Now if it's real rough, the same thing applies. We're going to come back, and the first thing we're going to do is we're going to lower these tabs a little bit. And again, guys, very little bit. Take your straight edge, document what you're doing. Even if you're not a racer, it's good to have that pad and paper, and I'll tell you why. You're going to sit out there and you're going to say, okay, this is the date today. I was out here, the water at the lake. It was, the water was, had a 3-inch chop on it, and then you start writing what I did. And then in about an hour or messing around, maybe a half hour, you'll go, oh, wow, I got this thing running real good in that conditions. Then you write down exactly what you did on that piece of paper. Use that for reference down the line. Next time you go out there 6 months from now, it might be 3-inch. But eventually what you're going to do, you're going to go out there one day, there's going to be a bunch of jet skis. Waves are going to be ridiculous, okay? And at that point, you know, you might have to just go slow, or you might find a way that you dialed your boat in and you had so much negative strut. And there's nothing wrong with making a mark. You could take a black small marker and put marks, and then, again, transpose that to paper. So you know what you did that day. Pretty soon you're going to have a log. And you'll use that log for a little bit, but then you're going to get to the point, and everybody does this, when you get good at it. A couple months go by, a whole summer, you're going to look at the water and say, oh, that's the conditions, and you know just what to do. So, same thing here. If you move the strut blade on an angle up, okay, like this, the bow goes up, the nose goes up. If you move the strut blade down, the bow goes down, okay? You want to use these trim tabs like wheelie bars. Remember, set this neutral to begin with. Set it up. So the tip of the tab, that's what's doing the work. That's going to make contact with the water first, and as the boat gets unstable, it's going to settle it down. We're not going to drive them in the water and force the nose down. We want to make it so the boat only uses the tabs when it's necessary. Okay? Same thing with the rudder. Remember we talked about pulling the rudder back. If you were to pull the rudder back a little bit, you'll free up the bow. Now let me give you a word of advice on a Gator, a Super G, okay? You don't need to free up the bow any more than the boat's designed to be freed up. That works much better on a dual rudder system. So if you've got the Mano Ray, the Magnum 57, or the Team Enforcer Pro, or something with our dual rudders, yes, if you pull the rudders back, it makes a big difference. But this particular boat, we like to tell you guys, keep them parallel. You'll find it. You can try it. You pull that rudder back a little, and you get this thing so loose it's hard to keep it in the water. Okay? But everything applies on this boat as it does on the race boat. All this stuff is adjustable. Okay? You don't have much adjustment up and down. I didn't touch that with the other boat or this one because it is predictable as a surface drive boat. Your shaft is coming out above the keel. So basically what you're going to utilize is the up and down action this way, the angled action, which is going to create the lift or drop in the bow. Okay? That's how that works. Okay, let's talk about something that I didn't on the other one. It's important. Rudder. Rudder adjustments. You'll notice that, especially we design these arms here, and we give you a bunch of different adjustments, okay? And you'll also notice this maybe. You ever notice why you'll see on the Silex it's a straight shot, or on the larger boats a straight shot, but on the Super G we do an offset. The offset's there basically because most of these people, most of the guys that buy this boat, women and guys that never done this before, are newbies. And we put an offset in there to take some of the force in case they mishaps happen and you have unnecessary force on the rudder. That allows it to take the force and the shock away from the servo. In racing conditions, this is not a good thing. If you have to do an offset in racing, make it very minor, nothing more than a ½ inch offset, because you want a rigid rod. And you'll notice these are 440 diameter rods, which are very important. 440 is about, I would say about 90 thousandths, I think that is. You need the large rods. Don't use a 256 or a thin rod. You've got to have rigidity. Okay, let's talk about adjusting it. As you move out on the rudder, you get less rudder, not more. So when you bring this clevis outward, you get less rudder. When you bring the clevis inward, you get more rudder. You're changing the leverage points on it, okay? I like to stay in the middle, okay, and then make the changes on the radio. But we give you the opportunity to mess around in any way you want, and there's nothing wrong with you guys making changes to see the differences. I actually promote that. Just do them out in the water a couple hundred feet, so you don't take a few docks out and boats with you. So get out there and get the idea of what it does to make these changes and see how the boat reacts and responds to it. Anyway, Chris is constantly telling me I got to stop, and this has been a great show, and it's, I think, number 10 this year. Man, we made it 10 shows already. We have one more left in December. It closes out our year for the first year of Full Throttle RC, and it's doing fantastic. I'm getting a lot of emails. Guys are calling me with excellent ideas. Excellent. And I had one guy, I got to bring this up, called me the other day, and I made a promise to him, a commitment. I think his name was Wayne, I believe. He said, man, Tony, he says, I need you to help me, tell me how to take the engines out and put the engines in, because there's nobody that's telling me how to do that. And I told Wayne, I made a deal with him, and I said, I'll tell you what, maybe the last episode of the year, I'm going to go through it, and it's going to be a pretty basic show, but it'll show you how to take things in and out, what tools to use, and the procedure to do so. So Wayne, thanks for that, and like I said, I promise you, and I will do it. As far as everybody else, have a good holiday. You know, it's getting close to Thanksgiving, and we're not running boats anymore. We still buy parts, okay? We're open every day. Keep us busy, would you please? Again, my name is Tony Casanova. Thanks for joining me today at Full Throttle RC, presented by Warehouse Hobbies.